Hi, this is a little video showing how to factor a polynomial completely and then sketching the graph. Here is the function x to the fourth minus 2x cubed minus 15x squared minus 4x plus 20. So the polynomial is of degree 4, right? The highest power is 4. So that means there are 4 complex roots. We can use the rational root theorem to identify the possible roots. So let's first take a look at the rational root theorem. And this is basically, take the polynomial and put it in standard form, highest power to lowest power, and then the constant is equal to 0. So it says, let's take a look at that leading term and the coefficient of leading term and call that q. Right, and then take a look at all the factors of q, whatever the factors of that coefficient are. And then let's take a look at the constant and call that p, and take a look at all the factors of p, right? Factors of the constant, I guess, of constant. We can do that. My spelling's sloppy. And then the factors of, right? So it says, given the polynomials in standard form, when we write a ratio of the constant, of the factor of the factors of the constant term over the leading coefficient, the factors of the leading coefficient, that they'll be possible roots. So another way to think about it is last over first. So let's take a look at our function and let's try to identify. Well, it's in standard form already. And so we can say, well, the coefficient of the leading term is just 1, and that's going to be represented by q. And then the constant is 20, so p is just going to be 20. So we need to take a look at the factors of these. Okay, so here we go. The factors of 20 are just plus and minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Remember, right? It can be plus or minus because a negative 2 times a negative 10 is going to give you a positive 20. So therefore, it's a valid factor. And then the factors of q are just plus or minus 1. So now we're taking a look at p over q, or the factors of 20, right, over the factors of 1. And since anything over 1 is always itself, right? Everything over 1 is always itself. So that means this 1 really doesn't mean anything, and all we really need to look at are the possible factors of 20. So these are the factors of 20. So these are our possible roots: plus or minus 1, plus or minus 2, blah 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 are possible. And remember, the roots, that's just another way of saying where does it cross the x-axis, right? Where is y equal to 0? So for one of these, right, when x equals whatever the root is, when x equals whatever, we know y is going to be equal to 0. So one of the ways we can do this is use synthetic division to find the possible roots, because when we come up with a remainder, then that's going to, a remainder of equal to 0, that's going to tell us it's a root. So let's just take a look at a root of 1. So we could rewrite this. The factor would be x minus 1. That's what the factor would be. And so using synthetic division, we just take the coefficients of each term. So the first term is 1, negative 2, negative 15, negative 4, and then positive 20. And we'll just use synthetic division, bring the 1 down. 1 times 1 is 1. We combine these two and we get a negative 1. 1 times negative 1 is just negative 1. We combine negative 15 and negative 1, we get negative 16. Oops, that's a 16. 1 times negative 16 is negative 16. And negative 16 and negative 4 is negative 20. 1 times negative 20 is negative 20. We combine these and we get a 0. Voila, this is a factor because we have a remainder of 0. And that means we're going to have x minus 1 is a factor, and the other part of the factor, well, here are the coefficients of the other part of the factor, because that's what these represent, the coefficients. So we have x cubed minus x squared minus 16x minus 20. That's the other part of the factor. But now we could just run this through synthetic division and just go 1, negative 1, negative 16, negative 20, and let's take a look at it for -2, a root of -2, and that would just be x plus 2 would be the factor. Bring the 1 down, and that's 1. 2 times -1 is -2. Combine these, we get -3. -2 times -3 is +6. Combine these, we get a -10. -2 and a -10 is +20. Voila, the remainder is 0. So this must be a factor also. And let's just take a look at that. So we get x minus 1, x plus 2. And then remember, these are going to be the coefficients for the remaining factor. So it's going to be -2, or no, well, these are the factors. -x squared. Oh, I don't have an eraser on this. Oh, shoot. No, maybe I do have an eraser. Oh, there we go. I'm moving so fast. Oh, okay. Well, you know what? I'm just going to rewrite it down here. The eraser isn't working. We're going to have, so I'll just scribble this out. X minus 1, x plus 2, and I'm going fast because I only have so much time to make this. So we have x squared minus 3x minus 10. That's the other part of the factor, right? And then we can factor this some more, and we can say x minus 1, x plus 2, and then factor, and we get x minus 5 and x plus 2. So our roots are equal to, roots equal -2, +1, and +5, right? Because we say x minus 5 just equals 0, and we get x equals 5. That would be this one right here. So that's a root. There they are. Now, so let's take a look. So we put these, you know, we can put these roots because it's where they crosses the x-axis, and we can put them on here. Now, we don't know what's going on. We don't know, you know, it's possible that the graph could come down and touch it and bounce back up. It's possible that the graph can go through it. So we need to figure out what's going on. So what we can do is set up a table and take a look at values of x to the left of -2, values of x between -2 and +1, values of x between 1 and 5, and then values of x to the right side of 5. So let's do that. We set up a table, and this is straightforward. So -4 is to the left of -2, and so on and so forth. And we know that when x is -2, f of x is going to be equal to 0. When x is 1, f of x is going to be 0. And when x is 5, f of x is going to be equal to 0. What I want you to do now is I want you to pause and find out what f of x is for each one of these values when x is -4, 0, 3, and 5. Pause right now. Do that. Pause, 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 pause. Okay. And now let's come back, and here's what they're equal to. So now let's take a look and see what's going on here. We can interpret this. We could say, as x moves from -4 to -2, look what's going on. It's decreasing. The graph is why f of x is going down. It's moving down, right? So when x is going from -2 to 0, all right, from -2 to 0, it's going from 0 to 20. So it's increasing. It's going back up. So it looks like it bounces off of -2. And when x goes from 0 to -1, y is going from 20 to 0. That means it's going down. F of x is going down, or the graph is going to be going down. As it goes from 1 to 3, it continues going down. Boom, so it crosses the x-axis there. When it gets to 3, or from 3 to 5, it looks like it's going back up from -100 to 0. It's increasing, right? And then from 5 to 7 is increasing and going to continue to increase. So this is the basic direction of what's happening. Let's take a look and see what's going on. And voila, that's what's going on. It's going down from -4 to 2, and then going up, right? From -2 to 0, and then down, and continues to go down past the root, and then come back up past the root of 5, and then continues on to infinity as x goes to infinity. I hope you found this helpful.